Hello everyone, myself Kusuma, Assistant Professor in Vivok Software and Application Development. Today we'll see data structure using stack concept. Before we'll see the definition of the stack. A stack is an ordered collection of the items in which an element may be inserted or deleted only at same end. Means we can store elements in a memory in some order. To insert an element into the stack, we use only one end, and to delete an element from the stack, again we are using the same end. Means inserting and deletion takes place at only one end, so that is called as a stack. So this end is called as the top of the stack, where the insertion and deletion takes place. So that end we can call it as a top. So the end opposite to the top is known as the base. So which is the element inserting of the top. So the opposite end of the top we can call it as a base. Stacks are sometimes known as a LIFO. Stacks we can also call it as a LIFO. LIFO is nothing but last in first out. So this is the diagram of the stack. So here insertion takes place at one end and deletion takes place at one end. So that is called as a top. For inserting an element we can call it as a pushing an element to the stack, while deleting an element we can call it as a popping an element from the stack. Next we will move on to the representation of the stack using array. So we can also represent stack using array using a one-dimensional array. Why we are using one-dimensional array means stack is the ordered collection of the elements. Before only I said, so to declare a stack in some order, so we can use a one-dimensional array. So the items into the stack are stored in a sequential order from the first location of the memory block. So while storing the elements in a stack, we use the one-dimensional array to store the elements to the stack in some order. So while storing the first element, the element in a memory must be stored in a 0th position, because in a array is a collection of elements. While storing the elements, always the first element will be stored on a 0th position. So always first position is considered as a 0. Next, a pointed top contains the location of the top of the element of the stack. Always in a stack concept, one top is required, because to insert the element into the stack or to delete an element from the stack, one point is required. So that point we can call it as a top of the stack. So a variable maximum stack contains the maximum number of the element that can be stored in the stack. To insert a element, one thing top is required, another one thing is maximum stack is required. Maximum stack means how much we can insert element. So total number of the elements holds the maximum stack. Next, if we attempt to add a new element beyond the maximum size, we will encounter a stack overflow condition. So maximum stack includes maximum elements that is to be inserted into the stack. If the maximum stack, if you want to enter element more than that maximum size, then stack will give an message as stack is overflow. So stack overflow condition is given because if the stack is full. Similarly, you cannot remove elements beyond the base of the stack. In such case, we will reach a stack underflow condition. So here we are inserting element at the one end, we are deleting an element from the one end. So we cannot delete an element from some other ends, because it is a stack, it uses only one end. So you cannot remove any element from the opposite side of the stack, means base of the stack. So the condition top is equal to maximum stack indicates that the stack is full, and top is equal to null indicates stack is empty. So top is equal to maximum stack. While inserting an element, if you give the condition top is equal to maximum stack, it means that it indicates the stack is full. If you give the condition top is equal to null, then it specifies that stack is empty. So this is the diagram of the inserting a stack into a memory location. So here I am taking 3 elements 10, 20 and 30. So always first element is considered to be as a 0th position. So 10 is stored on the 0th position, 20 is stored on the first position, 30 is stored on the second position. So here top is considered as a 30 and maximum stack. So maximum stack I have taken the size 4, but I have inserted only 3 elements, and base is considered as a -1. So here 3 concept is required: top, maximum stack and null. Top is nothing but top of the element, maximum stack is nothing but how much item you are going to store onto the stack. Null is considered as a -1 is considered as a null, it is nothing but base of the stack. Next, operation on the stack. To insert an element, you have to follow some operations to the stack. To delete an element from the stack, again you need to follow some operations. Let us discuss one by one. So first, stack operation is used. So stack operation means it creates an empty stack. Before entering an element into the stack, an empty stack must be created. To create an empty stack, you have to use the operation stack. Next, push item. Next operation is push item. You have to insert element into the stack. So to inserting element into the stack, you are using the operation push item. Push is nothing but inserting, item is nothing but elements you are inserting into the stack, top of the stack. After that, pop, it removes the top item from the stack. Pop is nothing but removing an element from the stack. So to remove an element from the stack, you have to use one operation. So that is called as a pop operation. Next one is the peek operation. So it returns the top item from the stack but does not remove it. Peek means it returns the top. While you are inserting, you should see which is the top element. So it will return the top element, but it won't remove that top element from the stack. So for that purpose, you have to use one operation. So that operation is called as a peek operation. So this is the concept of the stack using the data structure. Thank you.